Hi everybody, welcome back. We are going to talk about linear functions today. We're going to learn how to graph them, how to recognize different forms of them, and how to work with them. So what is a linear function? How do you recognize one? Let's have a look at a table of values and that might help. So if we have x and y, okay, so what we're doing is comparing two different variables, two different sets of values. So let's say that x is, we're looking at 2, 4, 6, and 8. And y by comparison, so when x is 2, y is, let's say, 5. For 4, it's 8. For 6, it's 11. And for 8, it is 14. Okay? So what's happening here is these are going up by 2's. And these are going up by 3's. If x goes up by the same value and y goes up by the same value, so if there's that pattern, then you've got a linear function, okay? So let's have a look at one really simple example of a linear function that we can all relate to, and that's working at an hourly job. So let's say you work at a job and you make $10 an hour, okay? So what's your income? Well, your income will depend on the number of hours you work in a given week or day, right? So let's say that, okay, so we're going to make a graph, and on the y-axis we're going to put income, and on the x-axis we're going to put number of hours worked. Okay, so if you work 0 hours, you make $0, right? If you work 1 hour, you're going to make $10. So we're going to say that this is 10, and we're going to put a little dot there, okay? If you work 2 hours, well, you're going to make $20, aren't you? Okay? If you work 3 hours, you can see where this is going. So there we have a simple scenario of working at a job where you're making $10 an hour. If you work 1 hour, so I can label these. If I work 1 hour, I make $10, 2 hours, I make 20, 3 hours, I make 30, 4 hours, I make 40. So your y-axis is this one here, and the y-axis is always the dependent axis, okay? So what happens here depends on what's happening here. It's like x is my question and y is my answer, okay? So this is your x-axis. The x-axis is the independent axis. Okay, so we would put time on the x-axis, for example, always, because time never changes based on something else. Time does what it does. It marches on. And so when you're comparing something against time, time is always on the x-axis. Okay, here, your income depends on the number of hours you work, not the other way around. The number of hours you work doesn't depend on your income. There are some situations where x and y are interchangeable, but they're quite rare. Okay, so you're always going to put the independent variable on the x-axis and the dependent variable on the y-axis. Now, what about if we wanted an equation for this? Well, it's quite simple, really. Your income, which is your y, is 10 times the number of hours you work, right? So if you're working 12 hours, stick your 12 in for x, and you have 120. Now, this could also be written in what we call function notation, which looks like this. So this would be your income based on the number of hours would be 10 times the number of hours you work. Okay? You could also write it in true function notation, which is f of x. Okay, so f of x is the same thing as y. Okay? And the x, of course, is the same thing as the h that we chose there. Sometimes you'll use letters like I to abbreviate the actual word that you're using. Most often, though, it's just f of x. Okay? In a lot of high school math, you get things like h at d for y. which would mean the height at a vertical or horizontal distance. You might get h at t, which is the height of an object versus time. Those are parabolas, and they'll be the subject of a different video. So this equation is the equation of a line in standard form. We also call it y equals mx plus b form, which is self-explanatory. We also call it the slope y-intercept form, okay? And that's because this here is your y-intercept, and that there is your slope, okay? So the slope of a line is the pitch of a line, all right? So there's basically 4 kinds of slope, and we'll go over them right now. So this is your xy grid, right? This is your y-axis, and this is your x-axis. And I'll stop putting that with every diagram, it'll take too long. So with your xy grid, if you have a line that goes like that, that is a positive slope. And m will be greater than 0 in that case. So we always read graphs from left to right, not the other way around, okay? So as you're increasing on the x-axis, as x is getting bigger and bigger, what's happening to y? Well, y is getting bigger as well. As a result, we say it's a positive slope. We know that it is increasing, therefore it's positive. Then we have this, okay? This is a negative slope. And for this, m is less than 0, okay? And for this one, as x increases, remember we read from left to right, as x increases, y decreases, okay? Then we've got, so this is x, this is y, something that looks like that. And this is a slope that is equal to 0, okay? I'm going to explain why it's equal to 0 in a minute when I do examples of all these 4, okay? This is also called a constant function. It's not actually a linear function, it's a constant function, because it's just y equals some number. So for example, if I have those 3 ticks there, then this is y equals 4. Okay, and while we're on the subject of this, let's talk about what the equations of the axes are. So on the x-axis, all the y values on the x-axis are 0. So this, the x-axis, the equation of the x-axis is y equals 0. All horizontal lines have a y equals equation, okay, truly horizontal. They have no rise and they don't rise, they don't fall, okay, so they're just perfectly horizontal. Those lines all have a straight y equals equation. The y-axis has the equation x equals 0, okay, so all perfectly vertical lines have an x equals equation. Now, vertical lines are, they're used a lot actually, more as asymptotes, which we'll get into in later videos. Asymptotes are kind of like invisible lines, and you can have horizontal, oblique, that is slanted, okay, or you can have vertical asymptotes. Vertical asymptotes are encountered starting in grade 11. But we don't really have vertical lines that depict any real-world situation because they're not functions, okay? And again, that'll be the subject of a different video. But for now, let's take the xy axis one more time and let's draw a vertical line, okay? So this might be 1, 2, 3, 4, 5, x equals 6, okay? All vertical lines have an x equals equation. There's no y in them, all right? So those are your 4 types of lines that you're going to see. And now let's talk a little bit more about slope and about the y-intercept. So slope is defined as rise over run. Or another way you can think about it is the vertical distance over the horizontal distance. So on this grid, let's graph a slope that is 3 over 2, okay? So if I have a point right here, slope of 3 over 2 will mean I'm moving up 1, 2, 3 and over 2. Okay, so this is my rise and this is my run. And so it would look something like this, right? Okay, the equation of that line, I've put the y-intercept at -2, so the equation of this line is simply y equals 3 over 2x minus 2. Okay, that's all there is to it. Now, what if I had this? What if I had a point here and a point right there? Okay, what's the slope between those 2 points? Well, I can go over 2, so that we have a run of 2, and we have a rise of 1, 2, 3, 4, 5. So this is steeper, okay, than this line, and the slope of this line is -5 over 2. Okay, so remember we had a run of 2, and this is why I like the word vertical, because I'm not rising here, am I? I'm falling, right? I'm going down, so it's not really rising. But it's a horizontal movement of 2, that goes in the denominator, the run goes in the denominator, and we've got a rise of 5 units. 1, 2, 3, 4, 5, to get from that point to that point. So, and because it's falling, we have a slope of -5 over 2, because as x increases, y is decreasing. And I can't tell what the y-intercept is here, but because it's just a very crudely drawn graph, but we can actually solve for that y-intercept. Okay, so let's do that up here. So how do we do it? Well, we're going to make our equation as far as we know it to this point. Okay, right now our y-intercept is unknown. This is what you have to do when you're given a graph or you're given the slope and you're given 1 point, and we'll get into examples of that. Or you're given a slope and 2 points, or you're given just 2 points, in which case you have to find the slope first. We'll get to that as well. And then once you have the slope, then you can figure out what the y-intercept is, okay? So how would we solve for the y-intercept here? Now remember that when you're solving equations, and this is an equation, isn't it? It's in function form, but it's an equation. However, we have 3 unknowns. What we want to know is what b is, because without both m and b, the equation of a line is useless, okay? So m or b might be 0, but we have to know that, okay? They're what are called parameters. So the slope and the y-intercept, these are called parameters. And we have to know what they are. As I said, they might be 0, one or both might be 0, but we have to know that. So we have to solve for it. Now, if we need to solve for b, that means we need to put numbers in y and x, because we can't solve one equation that it is in more than one variable. So I've put some dots in here, haven't I? Okay, I've got -1 and 2. So if I've got a point, -1, 2, that I know this graph runs through, then all I have to do is put the 2 in for the y, and the -1 in for the x, and now I'm down to a single variable. Okay, and now we're down to some of the equation solving we've seen in previous videos. We're just going to solve for b. So this is 4 over 2. Now the reason I'm changing it is because I know I'm going to have to add, subtract, whatever, this one to this one to get b by itself. And I know it has to be on 2 because I need a common denominator. So this here is going to be just 5 over 2. Because the 2 negatives multiplied make a positive, and then, we're just multiplying by 1. So the number doesn't change, and plus b. So I have 4 over 2 minus 5 over 2 equals b. Okay, so I've just moved the 5 over 2 over to this side so I can do the math with it. I'm essentially subtracting 5 over 2 from both sides. Okay, so 4 minus 5 is -1. So -1 over 2 is what b is equal to. And look, that's exactly where I am. Okay, it's not pretty, but it is right there at -1/2. So then what we do to finish this is we just write y equals -5 over 2x minus 1 over 2. Okay, don't put plus -1 over 2. We never put two signs together like that unless there's brackets around, and then that's a different situation. Okay? Okay, so how do we figure out slope? So let's figure that out next. Let's see what we do to solve slope, find slope of a line. Okay, so now we're going to see how we find slope. So let's say we have 2 points, 2 and 4, and -1 and -6, okay? And we need to find the equation of the line between those 2 points. Now, you can draw it. It's always a good idea to draw these. And I'm just going to draw them without grids because it's too time consuming to draw them with grids. And I'm just going to put the number of ticks that I need to draw each of my points. So there's my 2, 4. And -1, -6, 1, 2, 3, 4, 5, 6 is right there. So here's my line. A little wiggly, but there it is, okay? So it's a pretty steep slope. It's going to be somewhere in the neighborhood of 3, okay? Because for every 1 I go over, I go up 3. That's about what it looks like. So, and it's positive. That's another thing that the graph will tell us. Even the most crudely drawn graph can help you decide whether your algebra is right or not, okay? Or at least whether you should look at it again. All right, so here's the slope equation. M is equal to y2 minus y1 over x2 minus x1. Now, it doesn't matter which of these points is point number 1 and which one's point number 2. It makes absolutely no difference. You're going to get the same answer, okay? We're going to call this one x1, y1, and this one x2, y2, okay? So the subscripts just indicate that there's more than one y value that we're dealing with, but it's still the same variable. Okay, that's why we use subscripts like this. So let's plug these in. So according to how I've defined these, we have y2, which is -6, minus y1, which is 4. Now because of all the negative values, all the minus signs in a lot of these formulas, it's easy to make a mistake. So if you have double negatives, I really recommend that you put them in brackets. We're going to see in a minute that if I move these two around, call this x2, y2 and this x1, y1, we're going to see that it still works out to the same thing, but I'm going to show you how the double brackets work there. Okay, and then now, the other thing you have to make sure is that you map the values. So if I'm putting y2 first, like I did here, then I've got to put x2 first in the denominator. If I mix it up, I will get it wrong, okay? So you've got to make sure that you map them correctly. So it's -1 minus 2, okay? Now we just do the math. So this gives us -10, and that gives us -3, and unfortunately that does not simplify beyond that. So that's 3 1/3. Okay, I thought it would be about 3, and it is. Okay, and now let's see what it looks like getting that slope with this is x2, y2, and this is x1, y1. You're going to see it makes no difference, okay? So doing it this way, we're going to get 4 minus -6. Okay, so now this one is first. This one's first, and that one comes after. Okay, and notice the brackets that are there because of the two negatives. Really important to do that, okay? And then we have 2 minus -1. Again, using brackets because I have two negatives. So now we're going to take one extra step to take the brackets off. We're going to simplify, and we're going to get the same thing that we have here, okay? Now to finish this, what we're going to do next is find b. So right now we know that y equals 10 over 3x plus b, right? Now what we need to do is we need to fill in either of these 2 points for x and y to find b, because we have to know what b is. So b looks like it's about negative 1, negative 1.5, something like that. So let's find out. Let's use this number here. So we have 4 here for y. So this is another place where a lot of mistakes get made, because x is always listed first and y is always listed second in a coordinate pair, and it always, always, always is. And in the equation, y comes first. Often students transpose them, so watch that. It's an easy mistake to make. Okay, I've done it too many times. 4 equals 10 over 3, x is equal to 2 plus b. So 4 is equal to 20 over 3. Remember, the top times the top, the bottom times the bottom. The bottom here is just 1 plus b. I'm going to make this 12 over 3 because I need a common denominator. And minus 20 over 3 is equal to b. And we get negative 8 over 3 is equal to b, which is negative 2 2/3. All right, so again, my graph is a bit wobbly, but there we go. Okay, close enough. Close enough that I'm not suspicious of this answer. I'm pretty sure it's right. Okay, so now I just finish up this question by placing the b value that I found into my final equation. All right. Now I'm going to just erase this up here for a minute, and I'm going to write this up here, and then I'm going to get rid of the rest of this. So this equation is written in slope y-intercept form. There's another form of the equation of a line. There's a couple actually, but one that's dealt with quite a bit, or that you'll see quite a bit, is the general form. Now the general form looks like this. So the general form of a line, and students tend not to like this form. I don't blame them. It's kind of a useless form, but it's often used, especially in calculus. They like the general form a lot. And it looks like this: ax plus by plus c equals 0. And in this form, a, b, and c are elements of integers. Okay, so no decimals, no fractions, and a is greater than 0. So those are the rules. Okay. So how would we put this into this form? So to go from standard form to general form. Now, generally speaking, the standard form is the form that you can graph with. Okay, it kind of gives you clues or information without having to do any work about what points are on the graph of that function. And this one's no exception. You know, we would put our y-intercept at negative 8 over 3, and then we would go up 10 units and over 3, up 10 and over 3, and draw our line. Very simple. The general form doesn't really tell us anything useful at all. It doesn't tell us the y-intercept, it doesn't tell us the slope. But we do need to know how to put things into that form. So there's my starting point. So what I'm going to do is I'm going to move the y in between these two terms, because that's where it's supposed to be. It's supposed to be between the x term and the constant. So first thing I'm going to do is go 10 over 3x minus y minus 8 over 3 equals 0. Okay, so now to finish putting it into this form, we need to get rid of the fractions, right? So what we're going to do is we're going to multiply everything by 3. And we're going to end up with 10x, because these 3's cancel, minus 3y minus 8, because those 3's cancel, and then that's equal to 0. And so there's your general form, which, as I said before, is not a terribly useful form, but it is one that you need to know how to work with.